Madam, good afternoon, madam. மேடம் ஸ்டார்ட் பண்ணலாமா மேடம்? மேடம் மேடம் நீங்க பேசுறது கேட்கல மேடம்.
Yes sir, we can start sir. Yes, sir.
Okay madam.
In the name of Allah, the most beneficent and merciful, on behalf of PG and Research Department of Mathematics, the Abdul College, welcome everyone for this webinar. This is actually today's program. Today is second day. So we'll start this program with class by Mr. Muhammad Hakeem, Assistant Professor of Mathematics.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم قل هو الله أحد الله الصمد لم يلد ولم يولد ولم يكن له كفوا أحد صدق الله العظيم.
Thank you, sir. Next, I invite Mr. Suresh Kumar, Assistant Professor of Mathematics, for delivering the welcome address.
Good afternoon, everyone. I feel honored to welcome you all for the second and final day of the national webinar on applications of graph theory and communication technology. It is my great pleasure to welcome our respected and beloved Principal Dr. S.A. Sajid to this webinar. I am happy to welcome today's resource person, Dr. R. Jodhilashmi, Head of the Department of Mathematics, Mazharul Ulum College, Ambur. I welcome you, Madam. On behalf of our management, principal, head of the department, organizing committee members, I thank Dr. R. Jodhilashmi for accepting our invitation to deliver the upcoming lecture on mathematics approach behind communication technology. Finally, I welcome convener of this webinar, all the faculty members from various colleges, organizing committee members, and students participants. I welcome you all once again. We are all aware that we live in a world full of information. More precisely, we can say that the 21st century is the age of information. We have communicated lots of information through the technology from one place to another. For example, we have used optical fiber communication, digital communication, and so on. These communication systems rely heavily on mathematics. In this occasion, I thank our resource person for choosing such a wonderful topic. We believe that the next 1 hour will be fruitful for us. Thanks for the opportunity given to me. Thank you.
Thank you, sir. Next, I invite Mr. Saddam Hussain, Assistant Professor of Mathematics, for introducing today's chief guest.
Respected dignitaries, the most respected principal, head of the department, our faculty members, and my dear students, very good afternoon to one and all. It gives me immense pleasure to introduce our chief guest, of the day. Our chief guest does not require an introduction as she is a well-recognized person. She is none other than Dr. R. Jyotilakshmi, Assistant Professor and Head, PG and Research Department of Mathematics, Melvisharam College, Ambur. She completed her MSc Mathematics at Sacred College, Tirupattur in the period of 1999 to 2001. And she was the gold medalist in Sacred College. She had done her MPhil Mathematics at Madurai Kamarajar University. She accomplished her MTech IT at Satyabama University, Chennai in the period of 2005 to 2007 and obtained first class with distinction. She has done her full-time PhD in mathematics entitled A Dynamical Approach of Difference Equation in Digital Signal Processing under Tiruvallur University from 2012 to 2014. She has served as assistant professor and head of the department and lecturer in various colleges. Madam worked as a project associate in PG and Research Department of Mathematics at Auxilium College, Autonomous, Vellore from 2012 to 2014. She worked as an assistant professor, Fluid Dynamics Division, School of Advanced Sciences, VIT University, Vellore from 2014 to 2016. Currently, she is working as an assistant professor and head, PG and Research Department of Mathematics, Melvisharam College, Ambur. Her research experience, she shared numerous technical sessions as a chairperson, resource person, guest lecturer, dynamic speaker in national and international level conferences, seminars, and workshops. She is the editorial member of many international journals. She has attended 27 workshops, presented 62 papers, her 34 papers published in approved journals. She worked as project associate for the major research project approved UGC along with Dr. Elizabeth, head of the department, PG and Research Department of Mathematics, Auxilium College, Autonomous, Vellore. She received the travel grant from CSIR that to attend the International Congress of Mathematicians at South Korea in the year 2014. She has authored 2 books, Engineering Mathematics 1, Common to All Branches and Complex Analysis. She is multi-faced and multi-talented personality. We are very grateful to her for accepting our invitation and becoming the chief guest of today's webinar. I guarantee your next few hours will be delightful and memorable. I wish this webinar enlightens to all. We wish and pray that she should excel more and more in all her academic and research. We are eagerly waiting for your address, madam. Thank you.
Thank you, sir. Thank you, sir. Good afternoon to one and all gathered here. Sir, shall I proceed, sir?
Yes, madam.
Yeah, thank you, sir. Thank you, sir. Good afternoon to one and all gathered here with the blessings of Almighty, with the blessings of my parents, and with the blessings of my teachers. I wish to thank the management and the principal of C. Abdul Hakeem College, and I extend my heartfelt thanks to the convener of this today's webinar, Dr. Muhammad Rafi, and the coordinator, Professor S. Suresh Kumar, and the organizing secretaries of this webinar, Professor Sukumar sir and Professor Azaruddin sir, and members of this webinar, Professor Rahman sir, Dr. Sharif sir, Professor Hakeem sir, Professor Mukhtar sir, Professor Imran sir, and Professor Hussain sir, and beyond that, who arranged this webinar to taste the education and to taste the value of the mathematics to our students. Hats off to you, professors, and I wish to thank my beloved students who are very much eager to listen this webinar to arrive the applications of mathematics behind communication technology. I wish and thank everyone gathered here. With this introduction, I wish to share my PPT. So here, communication technology. So as Sukumar sir said, Suresh sir said, communication technology in the sense, we are going to share one information from one particular place to another particular place. So one information is going to share from one particular place to another particular place. That is called communication technology. So this information may be in the form of a JPG, or in the form of voice, or in the form of text, or whatever it may be, or in the form of audio or video, or whatever it may be. But anyhow, we are going to share some communication. We are going to share some communication. So here with the projecting my PPT. Here we are going to share some communications. We are going to share some data from one place to another place. So I know that the target audiences in this group are from first year to UG first year to PG final years. So now, my dear students, I wish to post very few questions to you. I need my beloved first year to answer this question, because we should know what kind of data we are going to transfer from one node to another node. So we should know the meaning of the data, because we are processing so many data. For example, qualitative data, quantitative data, like that. So we should know what kind of data we are going to process. According to that, we need to utilize the mathematics. So in my first question is, I request any one of the first years to answer this question. My question is, usually at what time you will wake up in the morning? My question is, usually at what time you will wake up in the morning? Any first years? If not, any UG students can answer this. Usually at what time you will wake up in the morning? My dear boys, any one of you? Now the question is open for any UG or PG students. Please, I need some answer from you, because based on the data only, we should know the mathematical behind the data to process. Usually at what time you will wake up? காலையில எத்தனை மணிக்கு நம்ம எழுந்துப்போம்? எத்தனை மணிக்கு நீங்க எழுந்துப்பீங்க? So that is my question. Okay, I'll say 5 o'clock. Will you agree? Every day, then you may ask in some question. Every day, madam, every day you are going to wake up by 5 o'clock, or not 5:10 or 5:05? Then I will change my answer. No, 5:10. Then again you will ask any question like exactly 5:10 you are going to wake up. Then I may change my answer like 5 to 5:30 or 5 to 6. So this is one numerical data I have. I will ask another question. How many first year students are attending this webinar? For this question, you may answer some 28 boys are attending. 28 first year boys are attending this webinar. That's maybe your answer. But why not you answer this question as 20 to 30 boys are attending? You couldn't. Am I right? How many first year students are attending this seminar? For this question, your answer should be some exact value like 20, 25, 30 or 27, whatever it may be. Now we can compare the numerical answer for the first and second question. My first question is, usually at what time you will wake up in the morning? So the answer is 5 to 6. So for this numerical value, there is some lower limit and there is some upper limit. 5 is the lower limit and 6 is the upper limit. So this is called continuous value. And my second question is, how many first year students are attending this webinar? In that case, you may answer some 20 or 25 or 30. But in this case, your answer is in the exact solution, like single value. You are posted as a single value as the solution. So now we compare these two numerical values. Now we need to classify these two numerical value. One value is having upper limit and lower limit, and one value is having there is no upper limit and lower limit, exact value we are having. So now I can conclude that upper limit and lower limit value is called continuous value and exact value is called discrete value. Now you should be very clear that what data you are going to communicate. Either it is continuous data or it is discrete data. So you should be very careful that the data which you have and what data you are going to communicate, that plays a vital role. According to that, you need to choose the mathematics. So if you choose continuous data, then you should choose differential equations. Once again I repeat, if you choose continuous values, then ultimately, obviously, you should take differential equations to process from one, to share the communication from one node, that is a source node, to destination node. Suppose if you choose any one value, exact value as a value to process from one node to another node, you need to, this value is called as a discrete value, and for that you need difference equations to process this discrete value. So now, once again I repeat, we have two types of equations. One is differential equations and another one is difference equations. If your input is having some lower limit and upper limit that is continuous, then obviously you should take differential equations as the source of equations to transfer your value, that is, you transfer your data from one node to another node, that is a source node to destination node. If your data, input data is discrete, that is exact value, then you should use difference equations as the media. So from selecting the equation itself plays a vital role. Once you identified, suppose some data is given to you, some data in the sense both numeric continuous data as well as discrete data are given to you. You can process the continuous data as it is. The data is called analog data. That data is also create some signal. That signals are called analog signals. And the exact value is going to create some signal. That signal is called digital signal. That is, discrete value is creating some signal. That signals are called digital signal. Now it is in your hand that you are going to process analog signal or digital signal. So everybody knows that this era is the digital era. So if anybody give the analytical form of solutions, that is analog form of solutions, then you can very well convert your analog form of solutions into discrete and the digital form of solutions. Then you can convert your analog signals in terms of this digital signals. Then you can utilize directly in any industrial sector or any manufacturing sector or any mechanical sectors or any sectors which is totally reliable and related to day-to-day life. So, but as I said, this era is digital era. So I'm going to focus only difference equations, not differential equations. Suppose anybody is provided differential equations, that is analog data to me, then I know how to convert my analog data into, that is differential data, continuous data into discrete data, then we can use. So this is the basic concept you should know. So now what is, I told you this is data, then you are going to communicate from one node to another node. So you are transferring the data from one node to another node. So here the problem is, the sender may be the human being, but the receiver is maybe the machine. In such cases, you need to process according, you need to focus such kind of equations, that is embedded equations you need to focus, because you don't know, because you are the sender in the sense, the receiver may be the human being, the receiver may be the machine, whomever it may be. If human to human communication, there is no problem. Human to machine means you need some embedded, that is embedded in the sense you need to merge two different types of equations. And so that concepts you need to focus. So with this introduction, I wish to play my PPT. Okay, so as I said, so then now the first topic of this presentation is exception handling. Exception in the sense error handling. So when I process, when I share the data from one particular place to another particular place, some error may happen. If error has happened, I may lose the data or I may not lose the data. If I lost some data, I should know how to recover my data. So that concepts are comes under this. I will tell you the mathematical and exact theorem behind this exception handling techniques. So as I told you, we are in the digital era, so we are focusing various difference equations. So for example, I will take three types of difference equations: stochastic difference equations, Riccati difference equations, and normal rational difference equations. With these three difference equations, I I will tell you how to travel some packet from source node to destination node. So first topic is exception handling technique. As I told you, exception handling techniques, that is, if any error has occurred, then I should know how to overcome that occur. And then that is the first one. And then the second one is, in that error, if I lost some data, then I should know how to recover the data, because these data communications are possible in telecommunication, mobile communication, satellite communication, and all. If I missed some data in satellite communication, means I should know how to recover the data. So with the help of this digital differential difference equations, we can retrieve the data. And I wish to show some various difference equations to reach our destination. And error, if we identify the error, I told you error. So what is error? So mathematically we are speaking that as error, but in the communication, engineers are use the term as noise. If noise is occurred, then we should know how to recover our equation. Based on that equation, you can recover your signal. So, and then in here we need some mathematical modeling technique also. And then why we are using some exponential decay means, when once you started to use the exponential decay, you can reduce the error as much as possible. So here we need to process the data. How to process the data in the sense? So for example, I'm going to show one. So here, suppose I'm going to draw, this is my process, data process. So here, this is my input. So this is my input. Then again, here I'm going to give the input. So here I'm going to give you the input. This is my input. Now this is my processor. This is my processor. Then after my input is going to be processed by digital processing algorithm, then I am getting the output. So I'm going to check this output with, this is the actual output, but I'm going to check this output. I'm going to check this output with the exact output. So I'm going to check this output with the exact output. This is called actual output. If the actual output and the exact output are equal, then I am going to accept this input as it is. If there is more deviation in the sense modulus of actual output minus expected output is less than epsilon, then I am going to consider this input as it is. That is modulus of actual output and minus expected output are less than epsilon. Then I am going to consider this input as it is. Suppose there is more deviation in this actual output and expected output, again I need to process this input value again. So please understand, this is your input now. This is your input now. So again I'm going to get some output. Again I'm going to check my second output with the expected output. So here I am getting different types of output. If I am satisfied with this output, if I am satisfied with this output, that is, the condition is modulus of actual output and expected output is less than epsilon, then I am going to consider this as it is. Otherwise, again I am going to process this input once again as a input. Then again and again I am going to do this. This is called recursive recurrence. So you know that the meaning of recursive recurrence. Recursive recurrence in the sense, it is a process of repeating the self-similar terms. For example, we can say Fibonacci series. So in that methodology only, we can identify error, if error is occurred, where that error occurred. So those things can be seen in the exception handling techniques. So still we need to focus some concepts related to difference equations. As I said, differential equations focus in continuous systems and the difference equations focus in discrete systems. So especially in the communication engineering, the digital communication engineering, the entire equations, 100% equations are rely on difference equations. In the analog systems, the equation, the analog system, analog communication, the majority of the mathematical background are based on differential equations. So in the communication technology, we are using both difference as well as differential equations. In the analog system, we are using differential equations. In the digital system, we are using difference equations. Now we are going to focus on difference equations only. As I told you, suppose they give the raw data as a differential equations, then I know how to convert the differential equations as a difference equations, and then I can use. So before going to conversion of the differential equations into difference equations, you should know what is difference equations, because in our curriculum we don't have difference equations as a UG syllabus, UG based syllabus. In PG we have the difference equations as a subject. Difference equations is a very simple concept. The consecutive difference between any two terms. If you consider yk, then you need to consider yk plus 1 or yk minus 1. The consecutive difference between any two terms, and then this is saved in the difference operator delta. That's it. In the first year numerical analysis itself, we are started to read this concept according to forward and backward concept. So the difference equation is very simple. Difference between any two consecutive terms. That's it. According to this only, Fibonacci series is developed. You can see based on the Fibonacci series, you can find out n number of applications, from beauty of the girl, from stock market or share market. So with the majority of the real-time applications like a golden ratio, everything also depends upon the Fibonacci series only. Suppose if they give the differential equations, I know how to convert the differential equations as a difference equations. So here, let us assume dy by dt, the first order differential equations, dy by dt plus a of t equal to bx of t. So here we are going to consider x of t, this is my input, and y of t, this is my output. So here t denotes the time, and as we know that a and b are the constant. Now I am going to convert this in terms of difference. That is what discrete is. How can we convert this means? We are going to keep this differential equation, that is the first term, first order differential equation term as it is. Then we are going to take this term in the right hand side. Then we are going to assume y of t with this y of n minus y of n minus 1 by t as the sample output, that is b of x of t minus a of y of t. Again it is comes under the consecutive difference between any two terms. So I can write y of n and y of n minus 1, or you can take y of n plus 1 minus y of n also. Then you can substitute this value, equation 2 into equation 1. Then you will get y of n equal to a1 y of n minus 1 plus b1 x of n, where a1 can be written as 1 by 1 plus ta, and b1 can be written as this. Again, you need to do the same procedure in the second order, that is d square y by dt square, and do the same thing for the higher order. So finally you will get a1 y of n minus 1, a2 y of n minus 2, and so on. So when you summing up this, you will get y of n is equal to, y of n is the output, x is the input. So k of n k equal to summation of k equal to 1 to n, this one a k of y of n minus k plus bk of x of n minus k. So when you take any communication engineering book, this equation should be the number one equation. That is, in the first chapter itself, you identified this equation in all kinds of communication engineering book. So this is the base, and this is the difference equations. So in this equation only, we are going to start at the data transfer or packet transfer. Now we should know the generalized mathematicians, the pure mathematicians and applied mathematicians and generalized mathematicians can take these equations, and then they verify that these equations form a digital signal. So already it is proven, but so we took this equation as it is to transfer the packet from one node to another node. So as I told, when I transfer the packet from one node to another node, so surely you will get some noise. Some noise will be affected your equation. So once the noise is affected, then you should know how to reduce the noise. So how to reduce the noise? Through some filters, you can reduce the noise. How to use the filter? What are the various filters available? That too, mathematically speaking, we have n number of filters available in the real world scenario. I will list some few filters. IIR filter. The IIR filter stands for infinite impulse response. And then the next one is FIR filter. FIR filter in the sense finite impulse response. And KF Kalman filter, EKF extended Kalman filter, uncentered filter, and Wiener filter. Why these filters are coming to usage means once the noise is occurred. Once I shared my data from my input to any other input, it is going to be travel in the space only. So once my packet is traveling in the space, surely the noise will be added. In that situation, we need to focus on two different things. One is noise, and another one is hackers or intruders. So what noise is in the sense some irrelevant data is going to be added with my message. So that is called noise. Sometimes this may give a very headache to process the data. And then another one is intruders or hackers. Hackers or intruders may interrupt our data, and then they can modify or they can change or they can do whatever the modification in our own data. This is also a dangerous one. So once you share the data from one node to another node, you should be careful in two different concepts. One is noise, that is some irrelevant data is available in your equations or available in your sequence or available in your message. So you should identify that and then you have to overcome it. That is noise. And then another one is hackers or intruders are going to be hack your data with the help of some signals. So in that case also you should be very aware. So here filtering in the sense once the noise is affected, then how to filter this. So once it is filtered, then you can very well check your equations. Your equation should be a precise and optimal solutions will be there. Then boundedness nature of the solutions are embedded with your equation. Then it is a stable one, and then periodical characters you can ensure, and then convergence will be ensured in your equations. With these concepts, you can understand that your noise level is reduced. So once you identified one equation, then you need to check whether the solution is exist or not. If the solution is exist, then you should analyze the behavior of the solution, that is the nature of the solutions, then whether it is a boundedness or unbounded or stable or not stable, converge or diverge. So you need to observe your equation periodically. So this is a normal one. Once you convert these equations in the stochastic nature, then you need to check additionally the random behavior also. So I will show the random behavior analysis through MATLAB also. So here, okay, what motivates to do these studies or these research in the sense? Simple logic. So this is the wireless communication, that is infrastructure-less communication. So this technology did not rely on big higher communication technology. We don't have infrastructure. We don't need any kind of infrastructure. In the olden days, when you want to speak, then you need the wired connection. So you need some infrastructure facility, only then you can utilize that. But nowadays, there is no need of any kind of infrastructure. If you can take your mobile, you can enter into the ground, then you can speak. But in the wired, you need some infrastructure. So this technology is a wireless technology. So you can utilize this in anywhere. And as I told you, so many filters are there. So in that filter, you should know what kind of filter you need to choose. That here also some mathematics are ready to help us. For example, IIR filter. IIR filter stands for infinite impulse response filter. So here, this IIR filter is involving more nonlinear components. So it is somewhat difficult to convert all the nonlinear component into the linear component. So once you left out, then you will go to FIR filter. But FIR filter need more hardware. That is, the hardware size is very huge. So in the beginning of the computer era, you know how big the computer is, such big infrastructure based filters we need once you choose FIR filter. So these are all the basic components while you have to choose what kind of filter you are going to choose. So that you need to focus the capability and the hardware and software component of the filters. So, and as I told, we are going to transfer the data. This data is going to be transferred from one node to another node. So through some signal only, we are going to transfer the data. So the data is nothing but, that is, the signal is carrying some information. So the information, as I told you, the information may be read by human or machines, whatever it may be. This information may be a textual data or audio data or some image or electromagnetic image or subsonic or ultrasonic or any data, any kind of data. These data are going to be processed. So that we have difference equations are the best equations to process the digital equations. So, and then as I told you, noise reduction. So the noise, how we are going to reduce the noise? What is noise? So some unwanted element are going to make an impact of your own equation, that is called noise. So here you need to filter the noise. Filter, please understand, filter is some mathematical operation to ensure to remove the unwanted component which is embedded, which is attached in your equation. So that is called a filter. Basically, filter is nothing but filter is a mathematical operation that is going to be remove or deduce or decay the noise term, that is irrelevant terms, which is available, which is attached or which is embedded in your equations. So that is the filter. So communication engineers, without mathematics, they cannot eliminate or they cannot attenuate noise without the help of mathematicians, without the help of difference equations, etc. So they rely on the mathematicians or applied mathematicians. So before going to exception handling techniques, I wish to convey one thing to you. So once you identify the noise, you are going to do the filtering process. How to identify the noise? Modulus of actual output minus expected output is less than epsilon. Then you understand that some errors, some noises is occurred in your equations. So you need to do some step-by-step algorithm or step-by-step some process. If you do some mistakes in your process, then here you may find difficulty that your noise ratio may be more higher and higher. If you misuse the steps and if you wrongly process, then your noise level may be multiple or triple or more and more. So that we need to remember this. And I told you one more word, embed in your equation. That is, the noise is embedded in your equation. Means already you have an equation. So how the noise is embedded in your equation means you are going to add one more term. Or for example, you have two images. So you can merge two images, then you will get some other image. Third type of image you will get. So image 1, image 2. When using Photoshop, you are going to merge two colors, means you will get third different color. In a similar case, you have equation 1 and equation 2. When you merge these two equations, then you will get the different properties. With the different inheritance of equation 1 and equation 2, you will get different equations. So now we are going to embed two equations, that is merge two equations. Then you will have different equations. For that different equations, you need to find out the actual output and the expected output. In this actual output and the expected output, you need to focus the difference. The difference is very less. Then you need to focus the solution converges to the particular fixed point or not, and then it reaches the stable. You can use any stable: asymptotic stability, global stability, local stability, exponential stability. You can ensure any one stability. That is enough. So more or less, each and all stabilities are travel towards to the particular fixed point. And then one more point you need to check here: equilibrium condition. What is equilibrium condition? Your function. If you import any function on your element, your function does not create any impact of your element. That is equilibrium here. So you need to check the equilibrium. That is f of x star equal to, again you will get x star only. So your function does not create any impact on your element. So that is called equilibrium condition. So you need to simultaneously, you need to check the equilibrium condition. So this topic involves 50% of pure mathematics and 50% of applied mathematics. If you are well versed in pure as well as applied mathematics, then you can use. And then another topic is also I wish to share. For example, suppose I may ask you just think about circle. So what will happen? What will happen? Circle means few can think the image like this circle. Few can think like the image like this circle. Few can be think like x minus h the whole square plus y minus k the whole square equal to r square, where h and k are center. That is, if it is origin 0, 0 is the origin, then your equation is x square plus y square equal to r square. So when I say circle, then we have two different types of perception. One is the circle is like this, and another one is the circle in the sense, if the center is origin, then we have x square plus y square equal to r square, where r is the radius. So for example, even for parabola also, we have a geometrical view as well as analytical view. So we have two different types of mathematicians. So one is circle in the sense, few thought like that, but a few thought x square plus y square equal to r square. So this is the analytical approach and this is the geometrical approach. So if you are well versed in geometrical approach, then automatically you are an applied mathematician. You can very well choose these kind of topic as your career. You can do research. Similarly, the same thing is applicable to parabola and hyperbola also. So parabola means some may remember some U-shaped curve, some may thought y square equal to 4ax. Similarly, for ellipse also, some x square by a square plus y square by b square equal to 1. So you should be, if you are very much talented in defining the equations, then you can proceed with the pure mathematics, or you can have a geometrical approach like this. Then really you can choose any kind of applications as your career. So now coming to this exception handling techniques, we can take any two equations, then you are going to merge these two equations, then you are going to compare the solutions. That is, you can just to check the convergence, just to check the solution exists or not. Then you need to observe your equations periodically. So these are all the mathematical concept behind this. So here I told you some equilibrium point, that is f of x star equal to x star. That is your function does not create any impact on your element. Then it is equilibrium point. So you need to check the equilibrium point, and then as I told you, local stable you can ensure, local asymptotically stable you can ensure, global asymptotically stable you can ensure. So once you ensured all those things, then you need to focus the concept of the solution, whether the solution is converges to the particular. Here please note that if the solution is converges or not, that is another question. If it is converges, your solution converges to the particular fixed point or not. So how can we arrive this? How? See, how can we check the solution? That too in the random behavior. We'll see. Let's see. Yes. So now I'm going to run this. So when I run this, here, please see, this is the noise measurement of my equation. That is in the, now I'm going to measuring the noise. So this comes under the stochastic behavior. So I'm measuring the random noise. So now I'm going to close this. Again, I'm going to run this. Again, I'm going to run the same program. So please see. So this image is different from the previous image. That is the random noise, because I told my program, or I give instruction to my equation to calculate the random behavior, random noise. You have to measure the random noise of my equation. So my computer is measuring the random noise. Once again, I close this. Again, I'm going to run the same equation. So here you are going to different types of noise. So I told the computer, I told my equation to arrive the random behavior of the noise, as well as I asked my equation to measure the noise. So again, once again I close this, again I'm going to run this. So again I'm going to get the different noise measurement. So this is called stochastic measurement, stochastic behavior of my equation. Apart from that, there is another behavior is called and one more thing I told you. Once I lost my data, then I should know how to recover my data. So that is also play a vital role. Once I lost my data, then through some polynomial like a legendary polynomial or any polynomial, you should know how to retrieve your data. So here we'll see. See, this is the image you will get. So through legendary polynomial, we are getting this. So here, please, we'll see here. So here, this is my positive points are begin here. Then I need to process P0 to P5. So my P0 lying here, P1 lying here, P2, P3 lying here. Though it travels both positive and negative, finally it reaches above 0. So I can consider the polynomial element coordinate, whatever you call P0, you can consider P1, you can consider P2, you can consider P3, you can consider P4, you can consider, and P5 also you can consider. If it fall in the negative, then surely if anyone fall in the negative, for example, this red color, this P2 fall below 0, then the system told you that no need to consider this P2, because once you consider P2 as your major coordinate, you may lose your data. That kind of indication the difference equations can give to us. So here this is very much used in share market. That is, once you choose this element, once you choose this time, then you may lose some of your money. That kind of indication it is going to give. For example, you are going to consider this is the control limits, and this will be the upper control limit, and this will be your lower control limits. According to that, it is going to be acted. So you can consider any kind of polynomial. So and then in the beginning I told you that the system is going to be process the numerical data. So in the first year itself, we focused on more numerical data like Range-Kutta method of order 1, Range-Kutta method of order 2, order 3, order 4, order 5, and then we can merge Range-Kutta order with some other method like a Butcher method or Adam-Bashforth method for predictor and corrector. So here we are calculating the values manually, but the system will give you the iterations, more and more iterations to us for various input values. So here also you can identify the noise value. So how can we identify the noise value? In the sense, so you can give any notations as lambda, rho, n, b1, a3, d, whatever it may be. So for each and every values, how many data we can use, how many data we can lose will be given with, you can identify it with the help of this equations, this MATLAB, and with this difference equations. So, and then once you checked all these values with the help of some softwares, then again you need to do some closed form of solution, that is analytical form of solution. That is, you need to ensure the convergence, you need to ensure the stability, and then you need to check the boundedness. Then periodically you are going to observe. So once you observed in the sense, then finally you need to check your values in the rational difference equations in the random value. Like you need to give the values like this, then you will get these values. That is here x of n, this blue and green. So blue x of n is the actual value, and then this green is an expected value. So here you can implement this to more and more filters. So then the noise level will be initially calculated. Then when you apply the extended Kalman filter, this will be your output. When you apply infinite impulse response filter, this will be your output. Then moving average filter, this will be your output. So yeah, all kind of median filter, Butterworth filter, FAR filter, Gaussian filter, weighted window filter, all kinds of filtered values will be displayed. So you can choose your own filter. So I told you here, while choosing the filter, you need to check the physical component, infrastructure based or infrastructure less. You need to focus all those things behind your filter choosing. At the same time, once you process the analog signal, then surely you need to rely on some continuous data. Some continuous data in the sense you will have some infinite data. For example, 10 to 20. After 10, what is the next number? Is it 11 or 10.1 or 10.01 or 10.001 or 10.000001? So there is an infinite numbers between the continuous case. For example, 10 to 20, after 10, before 11, so you have infinite numbers, infinite coordinates are there to process. So that is the major drawback of utilizing the continuous values. So surely you will get analog signal. That's why the total world is depend on digital signals, because in the digital value, they are giving exact value. There is no upper limit and there is no lower limit and then there is no range. Of course, the real time scenario are focusing not some major applications in the continuous case also, but in the communication technology, majority and the dominant applications are rely on digital values. So digital value in the sense, you need to focus ultimately, obviously, you need to focus the difference equations only. So these are all the various. Similarly, you can check with n number of values. So here, desired value. So this blue color is a desired, green color is the actual output, and then the red color denotes error. So here you can see, so here you can focus. So for example, I extend this up to 500 iterations. Up to 200 iterations, my error values are in oscillation behavior, more ups and downs are there. But after 200 iterations, my error stands behind zeros, but it is a travel in the ups and downs. So nearby zeros only it is a travel. So after 150th iteration or after 200 iteration, your equations are very fine-tuned. Now you can use your equation. In this case, in this periodical observation, when you check the closed form of solutions to this equation, then surely your equation should be the converged equation, converged towards the fixed point. It does not diverge, some boundedness will be there, then uniqueness will be there when you observed periodically. So this kind of MATLAB, with the help of this kind of MATLAB, with the help of some generalized math equations, you can pick some difference equations, then you can do any kind of analysis, like even when you travel your packet into some unknown environment in the sense like a space environment, or you can apply some equations and then check the tsunami data, it will be perfectly matched. So, but this should be the digital value. So you need to focus that this should be the digital value. So and then coming to the next one, and then the rectifications, as I told you, it is something with known and environment. Known environment is also there and unknown environment is also there. But your equation should behave in a stable manner in the known environment as well as in the unknown environment. In the known environment also you can encounter some errors. In the unknown environment also you can encounter some errors. Whether you encountered the errors or not, that doesn't matter. But your equation should be the stable one. When we observe your equation, then it should be periodically reliable to the end users or to the industrial experts. That has to be ensured with the help of Riccati difference equations. And then this equations is the non-linear equations as well as linear equations also. So as I told you, in the unknown environment, if you have some flexibility, then you can use some known constraints, or you can you choose some unknown constraints also. So whether it may be a known constraint or it may be that is a known one or unknown one. So known one or unknown one, your equation should be very stable, and then it has to reach the stability. So these are all the mathematical concept behind this. So now coming to the next one, that is the convergence. Convergence in the sense, so initially the convergence values is 2.5. Then after some iterations, then it is nearby 0. Then after this some 180th iteration, the system reaches the stableness. So when you observe periodically, the system reaches its stability. So Riccati difference equations rely on some matrix. So the input is based on your matrix. And then one more thing we tested here. What is it tested in the sense? Suppose I took some equation, then I reduce the noise. Now my equation is a perfect equation. Now again, what I do, I'm going to add some more noise, some more irrelevant data to the equation. Then when I run this, so this is my irrelevant data, and then this is my noise-free one. Now my ultimate aim is to remove this curve. To either it may be any curve or straight line or whatever it may be. This is not a reliable one. I need to remove this. So I need to do some mathematical process, iteration by iterations. Then finally, I am getting like this. That is, I am going to merge it. So this is merged. The difference between these two is surely less than epsilon. Till that you need to process. Now I once again repeat. So now you need to check the difference between these two. If this is not less than epsilon, then you need to do the process. Again, you need to check the difference between these two. Then difference between these two. So once the difference between these two is less than epsilon, then you can stop your iteration, or you can stop your process. So till that you need to proceed. So finally the modulus of less than epsilon, that is the decayed value without decayed value, the difference between these decay and without decay is less than epsilon, then you can stop it. As I told you, this is based on filter based and curve based, various polynomial based. So if you are comfortable with the polynomial, you can embed your equations and polynomial. If you are flexible with some filters, then you can embed equations and filter. So anything is possible. Now then, you can do some modeling also with the help of this. Modeling in the sense, you can observe the gain of your equation, you can identify the delay of your equation, you can identify the noise terms of your equation with the help of some modeling the equations. How can we model these equations? For example, this is my function, this is a transfer function. So we have so many functions, we have so many transformations there. You can import some transformation. For example, you know Laplace transformation is a transformation, Fourier transformation. So each and every transformation are having best in some identity. But in general, in the difference equations, you can use Z transform. So and then this function is a transfer function. But this function, I ask the system to model, or I ask the difference equations to model this, means the system is modeling like this. So this is called a mathematical modeling of this equation. That is 3 times of Z minus 1 can be written like minus 3 Z inverse, and then plus 3 Z power minus 2 can be written like this, and then minus 1 Z power minus 3 is written like this, and then these values 5 by 8, and then 1 by 16 is written like this. As I told, x of n is my input and y of n is my output. So this is also called as modeling. Similarly, we can model. So this is a combination of some rational function. So a rational function in the sense you have some numerator and some denominator, but here it is a combination of some fractions, perfect and imperfect fractions. So for this, how can we model? So for this kind of equations also, you can do modeling with the help of difference equations. So modeling and the noise reduction, different in the communication technology. Once you choose the mathematical modeling, or once you choose the noise reduction, the difference equation should be the best equations. And once you wanted to identify the hackers, then you need to do some crypt analysis. Nowadays, you know about the Bitcoin and all. This is called the cryptocurrency. So that is in a different area. So that is also the booming one. So once you wanted to do something in communication engineering, some mathematics, you have to interpret some mathematics in communication engineering means you should know the noise reduction and you should know the modeling of your mathematical equations. So here you should apply some transformation. Then after some transformation techniques, you can get your original signal also. Initially you will get the distorted signal, then you need to do some mathematical process, then finally you will get the original signal also. So this is also possible with the help of this difference equations. So once we come to the conclusion that n, you can process with n number of unknowns in the known environment as well as an unknown environment. You need to choose any kind of filter. The filter should be the adaptive filter. That is, it should help you. The filter should not trouble you. Your filter should help you. How can your filter should help you in the sense? It should be reduces your error. It should be reduces your noise term in your scale of time, so that you can choose any filter. Then you can, according to that, you need to check some mathematical concept like equilibrium point, and then convergence, and then unsolution exists or not, then boundedness, then periodical behavior, and everything you need to check. So these plays the vital role. So for that, if you want to proceed yourself, I wish to suggest the first major book is for R.P. Agarwal, Difference Equations and Inequality. Then LARD, an Introduction to Difference Equations. This is the prescribed textbook for PG students. And then if you want to do some research in the paper, then the very basic concept is convergence properties of difference equations in optimal filtering of non-stabilizable systems. If the system is stable, then no need to do any kind of process. If the system is not stable, then the problem encounts. There you should enrich enforce the convergence. So convergence properties of Riccati difference equations in optimal filtering of non-stabilizable systems. So these three should give you the basic and fundamental knowledge, and then you can do the analysis with numerical methods also with the help of some mathematical books. Thank you.
Thank you, madam. Any question from participants?
Actually, one more thing I want to convey. What are the equations I showed here? I need all the mathematical MATLAB programs are there. When the time permits, I will come there physically, then I will explain, then I will show, then I can match this with tsunami 2004 tsunami wave equations also. And then the major role of this difference equations is climate change. Nowadays we can calculate the climate change, that is the temperature increasing, the temperature also we can calculate with the help of this difference equations. That is another topic. Climate change also we can predict with the help of this difference equations. In that case also we can use difference equations. Any doubts?
Yes, participants, any doubts? Okay, madam. Thank you, madam.
Thank you, sir.
Actually, students are studying, they are UG and PG right
Yes,
now.
sir.
Actually,
Yes,
you are
sir.
taking communication technology,
Yes, sir.
so that they are new.
Yes, sir. Yes, sir. Yes, sir.
They may be new.
Yes, sir.
Yeah,
The
that's
students
what
should.
they are
Yes, sir.
hesitating to ask that.
Yes, sir. They should know the applications in that extent also. Mathematics, even the communication engineers, the DRDO scientists are rely on some mathematical concept only. So we are only giving the data to them. Our students should know. Even the DRDO scientists also rely on what we have to give the result to them. They are processing our result only. So that has to be known by the students, sir. So that is
Yes.
my main aim.
Yeah, actually, you are started very well, ma'am. Actually, in student point of view, that's what we are talking. Actually,
Yes, sir.
you started in the beginning very well. Actually, initially I thought actually how we are going to directly go computer technology to the mathematics student, but you started in the beginning very well. Thank you, madam.
Thank you, sir.
Thank you very much, ma'am.
Thank you, sir.
Now, I invite Mr. A. Faizur Rahman, Assistant Professor of Mathematics, to deliver the vote of thanks.
Good evening to all. I deem it a great honor to privilege to propose the vote of thanks on this memorable occasion. Let me first of all start by giving glory to the Almighty God for making this today national webinar on applications of graph theory and communication technology a resounding success. I thank our college correspondents to give permission to conducting this webinar in behalf of the Mathematics Association. I thank Principal of our college, Dr. S. Abdul sir, to give permission and full support to successfully conducting this webinar. I thank Sheikh Mohammad Rafi sir, HOD, and S. Suresh Kumar sir, Assistant HOD of the department, to give full support and encouragement to conducting this webinar. I thank our today resource person, Dr. R. Jodhilakshmi ma'am, Head and Assistant Professor in Mathematics, Mazrul College, Ambur, in his busy schedule, found to grace this occasion. I thank all faculty and participants from various colleges. I thank special gratitude to all my department faculty brothers to giving extraordinary support and backbone of this webinar as a great manner. Last but not least, I special thank to organizing secretaries of this webinar, Sukumar sir and Mohammad Azharuddin sir, making this webinar a resounding success. Thank you.
Thank you, sir. Thank you, madam.
Thank you, sir. Thank you, sir.
We have sent the link, dear participant. We have sent the link chat box. You fill it. Okay. Thank you, ma'am. Thank you, everyone.
Shall I leave, sir?
Yes, thank you, ma'am.
Thank you, sir.
Thank you very much, ma'am.